Hi everyone. Today we're going to talk about graphing linear equations when the equations are written in slope-intercept form. And just keep in mind, slope-intercept form is that form we talked about yesterday, where it's y equals mx plus b, okay, and the m represents the slope of the line, and the b represents the y-intercept. These are going to be important things for you to remember today. So just a quick review from yesterday. These are the two numbers we're really going to focus on, the m and the b. So the first important part to consider when looking at a linear equation is the slope. And the slope of a line, the official math definition, yesterday we said it's a measure of how steep the line is, but really the definition should read something like this. It's a ratio of the vertical change to the horizontal change, which basically just means that we're comparing how far the line climbs this way versus how far the line climbs that way. Okay? And sort of the shortened version we use is we say that slope is equal to rise over run, because rise means how far the line is climbing vertically, and run means how far it's going horizontally. Okay, so rise is up and down, run is horizontal. The rise has to do with the y coordinates, and the run has to do with the x's. Okay, let's try some examples. So, my first example, y equals 2x minus 3. Start by plotting the y-intercept. Well, my y-intercept here is in the b position, so it's the negative 3. So I'm going to go to negative 3 on the y-axis. So 1, 2, 3, and I'm going to put a dot right there. Okay. Then I'm going to look at my slope, and I'm going to make my slope into a fraction. So right now my slope is 2. I could rewrite that as 2 over 1. And then remember that slope is a ratio of rise and run. So 2 is my rise, and 1 is my run. Meaning that starting from that point that I already plotted, I'm going to rise 2 and run 1. And that's where my next dot is going to go. And then I could do that same thing again. I could rise 2, run 1, and put another dot there. Okay. Once you've done that a few times, then you can connect those dots with a nice straight line, and we'll see how straight I can actually make it here. Pretty good. Okay, and that would be your graph of that line. So remember, what that really means is that all the points on this line, whether they're the ones I marked or whether they're the ones in between, represent pairs of numbers, x and y, that would make this equation true. Okay, let's try now. Y equals negative 1/2 x plus 3. So, start at the y-intercept, which is the plus 3. So positive 3 on the y-axis is going to be 1, 2, 3 right there. Put a dot. Now my slope is written like this, negative 1 over 2. And when you're dealing with a negative fraction, that negative is allowed to go on the top of the fraction. It's allowed to go on the bottom of the fraction. It's just not allowed to go on both. So you never want to see this, negative 1 over negative 2. That would not be okay. Okay, because two negatives would cancel out and make a positive. So you can think about this any one of these ways, whichever is the most convenient for you. Probably one of these two is going to be the easiest to work with. So let's say I was going with this. This would mean that I'm going down 1, okay, because that top number is down, and then running 2 to the right. So from here, I would go down 1 and 2 to the right and put my dot right there. Okay. Same thing, let's do that again. Down 1 over 2, be right there. Now, let's say that instead of using this one, I had used this. This would mean that I was rising 1, but going to the left 2, because that's a negative 2. So I would go up 1 in that case, but then to the left 2. And hopefully you can see that if I put that point in right there, that it's all going to fall on the same line. So that's why it doesn't matter whether you put the negative on the top or the bottom. You just don't want to put it on both because that's really going to make the negative end up canceling out. And there's that line. Okay, let's try some more. Okay, 2y equals negative 3x plus 8. I do need to solve that for y first, and it looks like I left that on there for you. I didn't mean to do that, but I'm going to talk you through the process of solving for y. You should know how to do it because we've done it before, but just to make sure you know what I mean by that. So I'm going to take that original equation, 2y equals negative 3x plus 8. And basically in this one the only problem is that the y has a 2 attached to it, and I need to get rid of that 2. So I'm going to divide by 2, which means I have to divide this by 2 and divide that by 2. Now, this number here is going to end up being your slope. Okay, and slope we would much prefer as a fraction. In fact, when it's not a fraction, we turn it into a fraction so that we can have rise and run. So I know that you're tempted to type that into your calculator and make it negative 1.5, but we're going to leave it as negative 3 over 2x plus, and then 8 over 2 is 4. So you'll see that that matches what I left there for you. Okay, so I'm going to start at the y-intercept, start at the positive 4, and that means I'm going to go up from the 0, 1, 2, 3, 4, put a point right there. Okay. And then my rise is negative 3, and I'm getting that from right here, my slope. So that means from that point, I'm going to go down 3, and my run is 2, so I'm going to go to the right 2, and that's where my next point will go. Again, I could go down 1, 2, 3, and to the right 1, 2, and that's where my next point would go. And then let's connect those dots. Okay, all right. These ones are sort of weird. The equation y equals 4. Remember, we've talked about this equation before when we talked about functions, and what this means is that x can be anything you want, okay, but that y would have to equal 4. So x can be anything. And if I were there in class with you right now, I would have you yelling out things that x is allowed to be, but I'm just going to make some things up. I'm going to fix my pen here first. Okay, so let's say maybe x is negative 2. Maybe x is 5. Maybe x is 0. I always pick 0 as one of my options because it's easy to work with. Maybe x is 3. Maybe x is 107. Sorry, I was making that up as I wrote it. Okay, x can be anything you want. Y, then, always has to be 4. That's what this says, is that y has to be 4. No matter what x is, y has to be 4. So that means my y values are going to be 4, 4, 4, 4, 4. And you won't have to do this, you won't have to make this table every single time you want to do one of these. Once you see sort of the pattern, I think you'll be able to just jump in and graph them. So let's plot these points. Okay, so negative 2 comma 4. Negative 2 and then up 1, 2, 3, 4 would be right there. Okay. 5 comma 4 would be to the right 1, 2, 3, 4, 5, and up 1, 2, 3, 4, go right there. 0 comma 4 would stay right in the middle, and then just go up 4. 4 right there. Maybe you can already see what this pattern is going to be. 3 comma 4 is going to go to the right 1, 2, 3, and up 4, be right there. And really 107 comma 4 would go way out here on the x-axis, way over here where you can't see anymore, but then it would go up 4 and be in that same line. Okay. So hopefully what you're taking away from this is anytime you have a line that's y equals something, y equals a number, it's going to be a horizontal line. Okay, y equals a number is always going to be a horizontal line. Weird one. Now let's look at the equation x equals -2. That means that x, no matter what, has to be -2. We don't get a choice about x this time. -2, -2, -2. This time, y gets to be anything we want. So maybe 3, maybe 0, maybe -4, maybe -1, and maybe, I don't know, 7. Let's plot these points. So -2, 3 is going to be back 2 and up 3. Okay, so it would be right there. 2, up 3. Okay, my next one looks like is -2, 0. So that means to go backwards 2, but then up 0. So it's going to just stay right there. -2, 4 is going to go back 2 and then down -4. So it's going to land right there. -2, -1 is going to go back 2 and down 1. Hopefully again you're seeing this pattern. -2, 7 would go back 2 and up 7, which actually goes off the chart and would be up here somewhere. But hopefully you can see that this line is going to be a vertical line. So the big takeaway here is anytime you have x equals a number, you're going to end up with a vertical line. And one more thing about these functions. Well, I shouldn't say that, because what I want to ask you is this a function? Remember, something is only a function on a graph if it passes the vertical line test. And this, if I were to draw a vertical line right here, do you see that it would hit every point on that graph? It would cross more than once. So these equations, x equals -2, are the only linear equations that are not a function. Okay? So if I ever were to ask you, name me one linear equation that's not a function, x equals any number would not be a function. Anything else would be, but this one will not because it's a vertical line. Okay, let's try a few. Oh, and this is sort of just summing up what we were just talking about a second ago, but we'll go ahead and write this in here. So an equation in the form what becomes a horizontal line? Remember, horizontal lines were the first one we talked about, and that's where it's going to be y equals some number. Okay? And these lines are flat. So, and remember, slope is a measure of how tilted your line is, or how steep. So if it's not tilted at all, it has a slope of 0. Okay? And then an equation in the form x equals some number is a vertical line. Now these slopes, and we're going to talk about why this is later on, but remember we already talked about how these lines are weird because they're not functions. They're also weird because they have what's called an undefined slope. Okay. Symbol for that, by the way, is like the no solution symbol. Okay, and there is a difference between having a slope of 0 and a slope that's undefined, so make sure that you're using those correctly. Okay? Okay, let's graph both of these. So first equation, -2x plus 3, starting at the y-intercept, so starting at +3. It's going to be right there. And then my slope is -2, which I'm going to make -2/1. That means my rise is -2. So from here I'm going to go down 2. And then my run is +1. So I'm going to go to the right 1. And that's where my next point will be. And again, I always do it a couple of times just to make sure my line ends up somewhat straight. Okay, so there's my first line. My second line is going to start at -2. So I'm going to start right here. Whoops. right here at negative 2. And the slope is the same, it's negative 2. Okay, so this is what we were just talking about a second ago. Parallel lines are always going to have slopes that are equal. So if I give you a line and I say that my slope is 5, the slope of the line that's parallel to that would also be 5. Okay? If they're perpendicular, they are opposite reciprocals. And let's sort out what these words mean. Opposite means, in math, it means like negative and positive. So if a number is positive, you make it negative. If a number is negative, you make it positive. And reciprocals mean to flip your fraction over. Okay, so it's important to have those straight first. Okay, I'm going to do an example of that so you can see what I'm talking about. So let's say I have a line that has a slope of 2/3, and I want the slope of the line perpendicular to that. By the way, perpendicular lines, if you recall, are lines that cross at a 90-degree angle. So if my slope is 2/3, to make it perpendicular, I would take that 2/3 and I would make it the opposite, so I would make it negative 2/3. And then I would flip it over. And when I flip it over, that negative can just hang out up front. It wouldn't be wrong if you attached it like directly to the 2 or something, but it would end up being negative 3/2. So you can see that this and this, they are opposites of each other because one's positive, one's negative, and then all I did was take this one and flip it around to make that one. Okay, let's stash that up there. Let's try another one. Let's say I gave you a line with a slope of negative 4, and I wanted the line perpendicular to that. Well, you would take that negative 4 and first off make it a positive 4 because we want the opposite. And then I want you to imagine that that 4 was like 4/1, so that when we go to do the reciprocal, it would become 1/4. And that would be the line perpendicular to the slope of negative 4. Okay. So let's try this example. Consider the equation y equals 3x minus 5. Write an equation for a line that is parallel. And I'm going to stop right there. Parallel, the only reason it's telling me that is so that I know that I need to have the same slope. So when I write my equation, it needs to have the same slope as this one. And then it crosses the y-axis at 4. That's really your b value. That's your y-intercept. Okay? So if the line is parallel, it's going to have exactly the same slope. So the m will equal 3, because the m equals 3 up here. And the b will be 4. So the equation is just y equals 3x plus 4. Now notice that I did not use this negative 5 in there at all. People get really caught up with that. People want to throw numbers into their equation when they don't need them. Okay, this question is just saying I want a line parallel, so I want it to have the same slope as this one, but I want it to go through the y-axis at 4. So basically this would be as though you had one line crossing through the x-axis at negative 5, like this, and then another line crossing through at 4, like this. Okay, so this is the line they gave you. This is the line we wrote the equation for. Okay, and now that just looks like a big mess. Get that out of the way. All right, let's do the same thing now, except now I want a line that's perpendicular to all that. I'll give myself some room here. Except now I can't see my equation. It's okay, it was y equals 3x minus 5. Okay, if I want it to be perpendicular, I'm going to take that slope, which is 3, and I'm going to flip it and switch the sign and make it negative 1/3, and that's now my m. This right here tells me my b value, so I have that b equals negative 2. So when I write my equation, it's going to end up being y equals m, which is negative 1/3, x plus b, which is minus 2. Okay, or you could write plus negative 2. Either way is good. Okay, that's it for today. Let's try some homework out.